All right. Good afternoon, guys. Welcome to another math class. First, let me start with an apology for not having posted classes last week. Last week, I was going through a lot of trouble with my devices. My devices were giving me issues. Well, thanks to God, I've got a new set of devices, and we should be past our days of trouble. So, quick apology to you guys. I'm really sorry. It shouldn't happen again. We're going to be having consistent classes from now on. Yeah, let's move on to the business of the day. Today we're going to be working on trigonometry. This is a common topic we usually see in mathematics. And expect this topic to be tested very well in your exams. I believe we had a class whereby we introduced trigonometry, but just in case we didn't have a class, when we are working with trigonometry, we are working with ratios like sines, cosines, and tangents, as well as the inverse of their angles, where we have sec, that's secant, cosecant, and cotangent. Yeah, I know most people are only used to these basic trigonometric ratios, but today would work on these basic trigonometry ratios first, and if we have time, we'll move on into the inverse trigonometric ratios, which are secant, cosecant, and cotangent. Yes, the first thing you have to keep in your head or keep in mind when working with trigonometry is this popular mnemonic, SOHCAHTOA. This is going to be one of the most important mnemonic you'll be using throughout trigonometry class. And what does this SOHCAHTOA mean? It reminds us our basic trigonometric ratio. This is sine theta is equals to opposite over hypotenuse. So the O stands for opposite and the H stands for hypotenuse. Cos theta is equals to adjacent over hypotenuse. And tan theta is equals to opposite over adjacent. And that is the whole point of the SOHCAHTOA, to remind us of how to calculate our trigonometric ratios. There's something you have to keep in mind. Trigonometric ratios only apply to right-angled triangles, which means for you to be able to use trigonometric ratios, there must be an angle 90 in the triangle. One of the angle must be 90. If you don't have any angle 90 in the triangle, then you cannot apply these trigonometric ratios that we have here. All right, let's go on. Something else you need to understand is the sine, cosine, and tangent of something called, what do I call it? Let me call it special angles. Sine 30, 45, 60, and 90. Because this will be tested in your exams very well. Cosine of 30, 45, 60, and 90. And the tangent of 30, 45, 60, and 90 as well. So for sine, we have the answer to be, I think we've done this, but this is just a quick reminder. Sine is 1 over 2. You have to cram this. Sine 45 is 1 over root 2, or you could call it root 2 over 2. Still the same thing if you rationalize the sword. You have sine 60 to be root 3 over 2, and you have sine 90 to be 1. Okay, also you need to understand the sign of 0 too. Sine 0 is equals to 0. So let's go for the cosines. The cosine of 30 is the same thing as the sine of 60. So I could just draw a line that tells you both of them are the same. The sine of 60 is equals to the cosine of 30, which means we are going to be having this to be root 3 over 2. The sine of 45 is equals to the cosine of 45. They are the same. So we are going to be having this to be 1 over root 2. Let me divide this with white line so you know. Sorry. Yeah, sorry, give me a minute. Alright, let's go on. So the cosine of 60 is 1 over 2. The cosine of 90 is 0. And the cosine of 0 is equals to 1. Quickly, let's do for tan. Tan of 30 is 1 over root 3. For 45 is 1. For 60 is root 3. And for 90 is undefined. You can't find the tan of 90. Yes, undefined. It's not possible. Alright. Let's try and solve some questions with trigonometric ratios. Let's go to my school. And yeah, I think we solved some questions on this in our last class, but let's solve other questions on like a bearing, angle of elevation and depression. I think we did elevation and depression in our last class too. So let's just work on a bearing, and let's go from bearing into other trigonometric identities. Yeah, so because we want to go into bearing today, let me add some other information. When you are working with bearing, the first thing you always have to remember is your cardinal points. This is the north, this is the east, south, the west. Then the in-betweens, we have this to be northeast. We have this, we have this place to be southeast. We have this place to be southwest. We have the in-betweens to be northwest. And apart from this, while you're working on bearing, you need to know how your angles move. In bearing situation, this is your 0, and your angle moves in this direction, in the clockwise direction. So this is 90 degrees, 180 degrees, this is 270 degrees. And if you keep going in more revolutions, you get 360, and so you always have to know it. And another thing you need to understand is the difference between the bearing from and the bearing to. Now, what's the difference between from and to in bearing? If I have the bearing of A from B, then B is my starting point. But if I have the bearing of A to B, then A is my starting point. So I believe you should be able to understand this very easily. So if I have the word from, then the last location is the starting point. For example, the bearing of Lagos from Abuja, therefore Abuja is your starting point. But the bearing of Lagos to Abuja, then Lagos is your starting point. Is that clear? Imagine Imagine I have a question that says the bearing of x from y is, let's say, 145 degrees. How do I graph this? Where is my starting point, x or y? If you said y, then your answer is correct. So let me try and draw a bearing for y. Now, they said the bearing of x from y is 145. Don't forget this is 0. This is 90. Therefore, this is 180. Therefore, 145, has to be between 90 and 180. So it's going to be coming out in this direction. So this is going to be the bearing 145 degrees. Y, x. Because y is our starting point. So if you know how to find your starting point and you know how to put the angles in the right situations, then you should not have a problem with bearing. That is one thing aside. Another thing we need to keep in mind is when we are solving bearing questions, we apply something called the sine rule and the cosine rule. Now, the sine rule and cosine rule applies to non-rectangle triangles, which means triangles that do not have the angle 90 in it. So if you have a triangle whereby there is no angle 90, you're going to be using sine rule and cosine rule to solve most times questions on that triangle. Now, when do we know how to use the sine rule? We use the sine rule when there is any of these two conditions. There are two sides, one angle, or there are two angles, one side. So if we are given two sides and an angle, or we are given two angles and one side, then we can apply the sine rule to solve that question. When do we use this cosine rule? Yeah, we use the cosine rule if we have two sides and one angle, and we cannot apply the sine rule. So there are some situations whereby we have two sides, one angle, and the sine rule cannot just work. And what is that particular situation? If we are given two sides of a triangle, let me try and draw a triangle for you. Yeah. Let's say we have this triangle, and let's call this side A, and let's call this side B. If we are given the angle between side A and side B, the sine rule cannot work here. So this is the only exception to where sine rule cannot work with two sides, one angle. If you are given two sides and one angle, but the angle is the angle between two sides, then you cannot apply the sine rule here. So the only thing that you can apply in this situation is the cosine rule. So this is where we apply the cosine rule. When we have two sides and an angle, but the angle is in between the two sides, cosine rule works perfectly here. And the other situation whereby we can have, sorry for cleaning that. The other situation whereby we can apply the cosine rule is, I should not even clean this, let me leave it so I can refer to it later. Another situation whereby we can have the cosine rule is when we have three sides. If you are given three sides, no angle, you can apply the cosine rule. Alright, without wasting more time, let's try and solve questions. Questions on bearing and distance. Okay, let's just solve very basic questions, like number 1, 2, 3. They said x is a point due east of y. X is east of Y. So I have to start from Y first. Okay. So this is Y. Let's call this Y. And I said X is east of Y. Remember, I gave you that your bearing, this is east here, right? So east of Y is in this direction. So let me try and draw a line. So I said X is east of Y. Yeah? Coming? So X is east of Y. So let's call this point X. Yes? And Z is south of Y. Z is south of Y. It means now we are going down. South. Because south is downwards. Z is south of Y. Come in, sorry. So let's see, this is Z, south of Y. So let's call this point Z. 6√3 kilometers. We are given that in the equation. That Z is 6√3 kilometers south of Y. This is the question in question 1 here. It said if the distance XZ is 12 kilometers, that's the line from X to Z. The distance XZ if the distance XZ is 12 kilometers, find the bearing of Z from X. Don't forget now, the word there is from. So X is our starting point. And the bearing of Z from X is this angle. Is that clear? Now, to be able to find this angle, I just need this angle inside. Why? Because 90, 0, 90, 180, 270. If I remove this angle from 270, I'll be left with the remaining angle outside. Is that clear? So let's call this theta our angle of interest. And because there's an angle 90 in this triangle, we don't need to apply the sine rule or the cosine rule. We could just use SOHCAHTOA, our basic trigonometric ratio. And which trigonometric ratio applies here? This is the opposite of theta, and this is the hypotenuse of theta. And the thing has opposite and hypotenuse is sine. So I could go on and say sine theta is equals to 6√3 over 12. And I'm going somewhere. 6 here 1, 6 here 2, and we have sine theta to be equals to √3 over 2. Let's check the sine of what angle is equals to 3 over 2. Let's go and check. And if you look at it, the sine of what angle gives us √3 over 2? Sine of 60. Can we see? Sine of 60 is √3 over 2. So, therefore, that angle has to be 60. Is that clear? Okay, let's see if we can solve other questions. The answer is 60, option D. It said a sheep leaves H. So the sheep is starting from, okay, they said, sorry, a sheep H, my bad, leaves a port P. So starting from a port P, let's try and draw. So let's say this is port P. The sheep leaves the port P and sails 30 kilometers due south. South is downwards. So the ship just went down. So just leave here, 30 kilometers due south. Yeah? And it sails 60 kilometers due west. And it goes from south 60 kilometers due west. 30 kilometers, 60 kilometers. What is the bearing of H from P? So our starting point is, don't forget, this is where the ship is currently at. It's currently at H, or the name of the ship is H, and this is where the ship is currently at. So the bearing of H from P, so let's draw the line connecting P and H together first. The bearing of H from P is this angle. And to find this angle, we need to find this angle. Hey, my bad. We are not done with this question. Please. I just remembered our theta is 60 degrees, but that's not the bearing of x from z. I just remembered we didn't finish it. The bearing of x from z in this situation is 270 minus 60 is going to be equals to what? To 10 degrees. So my bad, our answer for this question is 210, option B. This is the answer, please. Just remember we didn't finish it. Yeah, just like we did for this question, let's find our angle of interest first, theta. And because there's an angle 90 in this question, this is the angle 90 here. We can just use trigonometric ratios again. This is the opposite and this is the adjacent, right? So I could just go on and say, which trigonometric ratio has opposite and adjacent? Tan. Therefore, we can say tan theta is equals to opposite over adjacent 30 kilometers. Therefore, tan theta is equals to 2. Now, there is no special angle that has 2 as the answer, so we have to use our calculator. So I'm trying to calculate this. So I want to get the tan inverse of 2. And if you press that, theta is supposed to be 63.4 degrees. So theta is supposed to be 63.4 degrees. Yeah, and let's see, is there any answer close to 63.4 degrees in the question? 60. This is the closest to 63.4. Option 2. Sure. But that's not the answer, though. That's just theta. And the bearing is from here. Look at it, the one in white. From here to this point. How can I find the bearing? One theta from 180, then I'm going to be having the bearing. So I could go on and say the bearing of H from P is 180 degrees minus 63.4. (180 minus 63.4), and we have 116.6, and that's the answer. So we have 116. So this is the closest to the answer. So option C is the right answer. So let's do something more advanced on bearing, not these easy questions that we are doing. All right, so let's continue. Now another part of the truth is bearing and distance is a topic that doesn't really come out that often. So so you might not see too many questions on bearing and distances. And even if you see questions on bearing and distance, it usually have, how do I put it? An angle 90 in it, usually. Let's go to another part of trigonometry that is always tested, which is, your knowledge of trigonometric ratios. Now in this question, they said, if sine theta is 3/5, find tan theta. How do we do this? Now let me try and graph a triangle. Sorry. Now let's say this is theta. It tells us that sine theta is 3/5, which means, if you remember, sine theta is opposite over hypotenuse. Therefore, the opposite has to be 3, and the hypotenuse has to be 5. What did he ask us to find? Tan theta. Tan theta is equals to opposite over adjacent. For those that don't understand how I know what tan theta is equals to, remember your soul katwa. Right? So it means for me to be able to find tan theta, I need to find my adjacent, which is this side. First, I can apply Pythagorean theorem that says hypotenuse squared is equals to opposite squared plus adjacent squared, which is equals to, now the hypotenuse is 5 squared, the opposite is 3 squared, and the adjacent is x, which is equals to 5 squared is 25, 3 squared is 9, and we have x. Collect like terms, x is equals to 25 minus 9, which is equals to 16. Sorry, this is x squared. If x squared is equals to 16, x is equals to what? 4, by applying square root. Therefore, if I know that here is equals to 4, then I know that tan theta is going to be opposite 3 over adjacent 4. Now the next thing I said, find the value of sine 45 minus cos 30. So let's do it. Sine 45 minus cos 30. Sine 45, we know is 1 over root 2. How do we know? I've given you special angles here. See it, 1 over root 2. I can call it root 2 over 2. Anyone that you want to do. Minus cos 30. Cos 30 is same thing as saying sine 60, which is root 3 over 2. Alright, the LCM of both of them is... to make this equation faster, let me write sine 45 as root 2 over 2. To make this equation very fast. Now the LCM of these two fractions is 2. The LCM is 2. 2 divided by 2 is 1 times root 2 is root 2. And 2 divided by 2 is 1 times minus root 3 is minus root 3. So this is the final answer, minus root 2 minus root 3 over 2. That's option D. They said if two smaller sides of a right angled triangle are 4 cm and 5 cm, find the area. Smaller sides, it means the non-hypotenuse sides. Sorry, let me draw a proper triangle. They say the smaller sides are 3 and 4. Right? Oh, sorry, 4 and 5. Find the area. What is the formula for area of a triangle? 1/2 times base times height. The base is 5, the height is 4. So it's going to be 1/2 times 5 times 4, which becomes 2 here 1, 2 here 2, 5 times 2, 10 centimeters squared. Easy. That's option A. Yeah, the next question. They said the area of triangle PQR is 12 root 3 centimeter. Listen, whenever you have a triangle like this, yeah, the one in question 4, they gave you two sides and they gave you the angle between both sides. See, they gave us 8, they gave us Q, which is the other side, and they gave us 60, which is the angle between 8 and Q. And you are told to probably find the area. The formula you use is this formula. Well, there are 3 formulas for area of a triangle. Formula 1, area of a triangle. Let me write it, area of a triangle. Probably you should note this now. Formula 1 is half times base times height. And we use this for right angled triangle. What if they give you an angle with 2 sides and the angle between 2 sides? We use this new formula. Half times A times B times sine theta. And theta is the angle between A and B. Let me give you an example of this. Imagine this is a triangle. This is side A and this is side B. This is theta. To find the area, we use formula 2. And there's another formula, or the formula 3 called Aaron's formula, that is given as S into bracket S minus A into bracket S minus B into bracket S minus C. This formula is used when 3 sides are given. So if they give you 3 sides of a triangle and they told you to find the area, you use the Aaron's formula. Now, the applicable formula for this question is formula 2. And let's try and redraw the triangle that was given to us in the question. We have 8, here is Q, and here is 60. And it told us that the area is 12 root 3 centimeters squared. We are told to find Q. What is the formula for area? Formula 2. Area is equals to half AB sine theta, or half times A times B times sine theta. Same thing. Now let's start filling in let's start substituting. Area is 12 root 3 equals to 1/2 times our A is 8, our B is Q, and our sine theta is sine 60. Right, so let me just multiply both sides by 2. So I'm going to be having 2 times 12 root 3 is equals to 1 times 8 times q times sine 60. Why? Because times 2 we cancel this place. Did you understand it? 2 times 12 is 24, so I have 24 root 3 is equals to, well, 8q sine 60. But sine 60 is root 3 over 2. So I have 8 times root 3 over 2 times q. I can still multiply both sides by 2 again, so that I can cancel the 2 at the bottom. And I'm going to be having 48 root 3 is equals to 8q root 3. Divide both sides by root 3. Then I have 48 is equals to 8q. Now I can divide both sides by 8. And q is going to be equals to 6. Easy. Now question 5 says, if cot theta is 8 over 15, cot theta is equals to 8 over 15. Now, in case you see cot, or let me introduce you to inverse trigonometric ratios. We have basic trigonometric ratios, sine theta, cos theta, and tan theta. But for inverse trigonometric ratios, we have sec theta, and sec theta is 1 over cos theta. We have something called cosec theta, and this is 1 over sine theta. And we have something called cotan theta or cot theta, and this is 1 over tan theta. So therefore, they told us that cos theta is 8 over 15. Therefore, remember that 1 over tan theta is equals to 8 over 15. You are going somewhere. If I apply inverse on both sides, if I do reciprocal on both sides, I'm going to be having tan theta is equals to 15 over 8. Reciprocal means take down, up, take up, down. Is that clear? So if I do reciprocal on both sides, I'm going to be having 15 over 8. What do you ask us to find? It asks us to find sine theta. Something else you need to know is in a triangle, okay, you should know this already. Let me try and draw the triangle very fast. Now let's say this is theta. Tan is opposite over adjacent, right? So this is the opposite 15, and this is the adjacent 8. To find sine, I need hypotenuse. Why? Because sine theta is opposite over hypotenuse. Is that clear? So to find hypotenuse, I just quickly do Pythagorean theorem, and I say hypotenuse squared is equals to 15 squared plus 8 squared. 15 squared is 225. 8 squared is 64. So if you press your calculator, I'm trying to 225 plus 64. What does that give us? 289. Yes. Then hypotenuse is going to be the square root of 289. Is equals to 17. This is understood. Now, therefore, sine theta is going to be opposite. Opposite is 15. Hypotenuse is 17. 15 over 17. Option B. Yes, they said use the graph of sine theta to estimate the value where sine theta is 100%. This is 0 minus 0.4. It's touching it here. Let's see, this between 90 and 80 is how many lines? 1, 3, 4, 5, 6. So 90 is divided by 6 is 15. So each line represents 15 degrees. Right? So it makes us to count. So let's trace back. This point, if you trace it up, this is 180 plus 15, 195 plus 15, 210. Are we together? 210. But look at it, the line is in the middle. It's not exactly, it touches in the middle. So it means it is something above 210, but not up to 220. So let's say it's 218. Let's say it's 218. Now let's trace the other side, 0.6. Keep drawing the line. Follow my line. No? It's touching here. So let's start counting. 270 plus 15, 285. 285 plus 15 is 300. Right? $270, 285, 300. Now this is more than 300, but it's less than 315. Why? See 315 here. And I've touched it before 315. So the answer must be 223 and 305. It's very complex to explain, but I don't have a graph. If you have a graph, if you trace it, you'll understand it more easily. Let me zoom out back. Yes, they said if tan theta is 8 over 15. They said if tan theta is equals to 8 over 15. They said evaluate sin theta minus cos theta. Over sine squared theta minus sine theta. Alright. So let's quickly draw the triangle. Let's say this is theta. Opposite is 8. Adjacent is 15. Because tan theta is opposite over adjacent. Then let's find the hypotenuse. Hypotenuse squared is going to be equal to, well, I know this is 17 already. We have done it before. See it here. See it here. So I don't need to be wasting my time. So therefore I know that in this situation, sin theta is equals to opposite over hypotenuse, 8 over 17. And cos theta is going to be equals to adjacent over hypotenuse, 15 over 17. So that means I substitute. So I'm going to be having 8 over 17 minus 15 over 17 divided by 8 over 17 squared, all together, minus 8 over 17. Alright, for the top, the LCM is 17. So I could just do 17. And I'm going to be getting 8 minus 15. If you do 17 divided by 17 times 8, and you do 17 divided by 17 times minus 15, you will arrive at this answer here. What about for the bottom? 8 squared is 64. 17 squared is 289. Minus 8 over 17. The square root of 17 and, sorry, the LCM of 17 and 289 is still 289. 8 minus 15, quickly, press your calculator, is negative 7. So I have negative 7 over 17 all over. The LCM here is 289. 289 divided by 289 is 1 times 64 gives us 64. 289 divided by 17 is 17 times minus 8. What do we have? Minus 136. Which leads us to minus 7 over 17 all over 64 minus 136. What does it give us? Minus 72, good, over 289. We are almost done. Allow me to change this division sign to times. So it's going to become minus 7 over 17 times 289 over minus 7. Sorry, over minus 72. To change division to multiplication, down goes up, up goes down. Very, very easy. Now minus cancels minus. 17 here 1, 17 here 17. So I'm going to be left with 7 times 17 over 72. Which will take me to 119 over 72. I don't think anything can go in both of them. Yes, that's option B. I think we solved all the questions in this section. Do you still have anything on trigonometry? Okay, let's check on geometry and trigonometry. Alright, they said in triangle MNO. So let me try and grab this. Let's say we have a triangle MNO. Let's call this M. Let's call this N. Let's call this O. Alright. MN is 6 units. 6 units. MO is 4 units. And NO is 12 units. 12 units. I said if the bisector of angle M, what is the bisector of angle M? It's a line that divides an angle into 2 equal half. Let me try and draw a bisector for M. I'm coming. Now this is the bisector for angle M. This line. Now we're told that, sorry, give me a minute. Point eraser. The bisector of angle M meets NO at P. So look at it. They said this line meets line NO at point P. So this is point P. They said calculate NP. All we can do here is say, since this bisector is dividing these two angles into two equal angles, right? I could say, what did it say if you find NP, this place? One way I could say it is I could say the ratio of MN to MP is going to be equal to the ratio of MO to MP. This is the correct relationship because they have the same angle. But now we don't have MP, so let's find another relationship that can work. I can say the ratio of MN to NP is going to be equal to the relationship of the ratio of MO to OP. In case you don't know what I'm doing, the ratio of this line, see this line to this line, we're using the ratio of this line to this line. Does it make sense? No, it makes sense over time. And if this place is 12 units, NO, from here to here, if this is 12 units and this is X, definitely this is going to be 12 minus X, right? So let me use relationship 2. Why? Because I have MN, yes. I have NP, yes. I have MO, yes. And I have OP, yes. I have all that I need. Is that clear? So let's go on and solve it. So we are going to be having 6 over X is going to be equals to 4 over 12 minus X. Cross multiply. I'm going to be having 6 into bracket 12 minus X is equals to 4X. Which takes me to 6 times 12 is 72. Minus 6X is equals to 4X. Call it like terms. 72 is equals to 4X plus 6X. 72 is equals to 10X. X is equals to 7.2. Final answer. Yes, option B. This is geometry. Let's just answer one more question and we call it a day. See this triangle, let me see if I could draw it. So we have two parallel lines. How do you know they are parallel lines? They are going in exactly the same direction. Once you see these arrows on lines, they are parallel. We do that this is 50 degrees. We do that this is 30 degrees. And they're telling us to find X. How do we find X? It's very easy. First, there's something called vertically opposite angles that are opposite each other, forming an X shape. Vertically opposite angles are always equal. Therefore, we know this angle, let me be doing it, the one that we are solving in white. So I know this angle has to be 50 degrees. Are we good? Now, if this angle is 50, sum of angles in a triangle is equals to 180. Therefore, this has to be 100 degrees. Are we good? So this is 100 degrees, then this place, x, angle on a straight line is equals to 180. So x has to be equals to 80 degrees, the balancing angle. Easy. Yeah? Let's call it a day. Have a nice day. See you in our next class. Bye.